So in our last video, I introduced these basic trigonometric proofs of the following relations, and it's just for you to take note of these relations. So I'm going to be applying this, so you can probably screenshot this or always rewind if you want to make reference. I'm going to be using this beautiful trigonometric formulas on the board to solve the problems that I presented in the first chapter of this video. So the first question we had was to show that one over 1 minus sine theta plus 1 over 1 plus sine theta is equals to 2 sec squared theta. So that was one of the first question. We show that this is equals to the right hand side. You can do both ways, but for now we'll look at the left hand side giving us the right hand side. So the first thing we should do is pertinent that we look for the LCM of this and this. Since we have two different relations, so we can have the LCM of this and this giving us 1 minus sine theta times 1 plus sine theta. This can just the normal way you handle a fraction. This will cancel this, then you multiply this with this, you have 1 plus sine theta. You have a central plus. This also will cancel this, and you have this multiplied by the numerator here, and you have 1 minus sine theta. So that's what we have, and we see it's obvious that if we collect like terms, this will cancel this, and we're going to be having 2. So 1 plus 1 is left there, 2 over this. So we can apply the difference of two squares, because you have 1 minus sine squared theta and 1 plus sine squared theta. So we can have this as 1 squared minus sine squared theta, and this is going to give us 2 over 1 minus sine squared theta. Among our relations I gave you on your screenshot, you discovered that this is cos squared theta. From what we have, this is cos squared theta. So this is just going to give you 2 over cos squared theta. And remember, I told you that this is going to be 2 times 1 over cos squared theta. I remember I told you that 1 over cos squared theta, 1 over cos theta generally is sec theta, secant theta. So this is secant theta times 2. That gives us 2 sec squared theta, and that's, we have that proven. So we move over to the next question, which is more like a trigonometric equation. So that's more like, so this is the first question, and we'll look at the second question. So this is like, we have the question says sine in the first video. Question says sine square theta plus cos square theta, cos theta, I'm sorry, just cos theta is equals to minus 1, and the answer varies between 0 and 360 degrees. So you saw something like this, between 0 and 360 degrees. So we have to solve this out. And the first thing that we'll do to help us, remember that this sine square theta can be written as 1 minus cos square theta. So we can do that. So we can rewrite this as 1 minus cos square theta plus cos theta minus 1. So we can have that. We can arrange this to give us, we can arrange this properly to give us, or kind of move everything to the right hand side. We're going to be having cos square theta. So we have this over here, cos square theta. If this also moves, you're going to be having minus cos theta, and this moving off also here, we're going to have minus 2 equals to 0. So this is just arranging this so that we have this. We're going to say let x be equals to cos theta. So replace cos theta with the variable x, and you see we're going to be having x squared minus x minus 2 equals to 0. And this reminds you of what I discussed on one of my videos, and that is a quadratic equation. A quadratic equation, we can apply the quadratic root formula to solve this. So we can have a as 1, we have our b as minus 1, and we have our c as minus 2. So we can apply the quadratic root formula to solve this immediately so that we can get our answer. So that is what we have. A is 1, b is minus 1. So we bring in this formula, the quadratic root formula. This is the quadratic root formula to find the value of x, and we substitute these values into this. We have this. This is going to give us 1 plus or minus the square root of this is 8 plus 1, and that's 9. 9 divided by 2, and that is going to give us two answers. That is 1 plus 3 over 2, or we take 1 minus 3 over 2. So we have these choices, and that this is going to give us obviously 2, and this is going to give us minus 1 minus 2, sorry, minus 2 over 2. So we have our answer to be, our x value to be 2 and minus 1. So this is our, but that's not what we're looking for. What we're looking for is cos. We said let x be equals to cos theta. So it means that cos theta is equals to 2 here, and cos theta is also equals to minus 1. So this is what we look at. So, but I'll prefer you to take this because we were told and we're given a very strict warning that our theta is just between 0 and 360 degrees. So we have theta here. You can use your calculator, you can use your graph book, you can use your log book, your cosine table. You see that theta is going to be equals to pi. The cos inverse of this, cos inverse of minus 1 is pi. And if you look at the cosine graph, if you want to understand it better, see the cosine graph, you see theta is pi when theta is pi when the function itself, the cos function, is minus 1. And again, you were told that your answer should be between 0 and 2 pi, and between 0 and 2 pi, 360, theta is only equals to pi when the function is equals to minus 1. So this is what you have as your answer. So we go ahead to solve the fourth question. So the third question is your own personal exercise. So you try to solve that. So the fourth question, we have that on the board. We have to show that this at the end of the day is equal to the right hand side. We have to go to this here. We can solve this very fast. So that is, we look at this. We have cos theta. We write cos theta, and we have that sec theta is 1. Remember that this is 1 over sine over sec cos theta. I'm sorry. This is 1 over cos theta. Take note. Is 1 over cos theta, and tan theta is sine theta over what cos theta. So we'll take note of that. We can look at that algebraically for which to have this is like saying over 1. So we can take the LCM of that. So we have the LCM to be cos theta. Cos theta times cos theta is going to give us cos square theta, and this will cancel this. So we have this just to be 1, or divided by sine theta over what cos theta. Sorry, this looks awkward at the moment, but we have to bear with it. This will cancel out as common denominator, so they cancel out as that. And what we're going to have in left here is simply cos square theta minus 1 divided by sine theta. And you know, this is from the relation we discussed in the first video. This is the same thing as sine square theta, and we use that here. This is remember cos square theta, that's 1 minus, so sorry, I'm going to take this out, sorry about that. So this is 1 minus sine square theta minus 1 divided by sine theta. So it's obvious that this will take themselves out. So you simply have minus sine square theta over sine theta. So if we do a cancellation, we have minus sine theta. So that is what we have. So I'll take this up. It's like saying minus sine theta divided by sine theta. So this, we have a cancellation here, so we just have minus sine theta here. So this is a basic proof to these trigonometric functions. You can stay tuned to more and more videos on Sami KMF. This is how well I can go when it has to do with this. If you have any challenging question on trigonometry, you can email it to me. Do well to share this video. Do well to also like and subscribe to my channel. Thank you and bye.